should prove that A union B intersection C is equal to A union B intersection A union C. Now, in set theory, these two things I want you to make sure you also take note of it, including what we have been talking about so far. Now, whenever you see union will be represented by or when you see intersection will be represented by and. Now, we want to start with this particular proving now. So we want to start the proving of this expression here now. So we can now bring a particular value and let it be the value that will be a member of such this set now. So we can now say that let x be a member of this question given to us. Now we are going to take this part now, taking the left hand part now. Be a member of A union B intersection C. I want to divide the part. Let x is a member of A union B intersection C. Now, this will mean that x is a member of A. What do I call this particular expression? Or union means or x is a member of what? X is a member of B intersection C. We have divided this particular set into two parts now. I take this one in part, one in part. X is a member of A or X is a member of B intersection C. That is the first step here. Now, we can now go ahead and say that X is a member of A or X. Now, as we have it here now, we can now separate these two again. X is a member of B. What do I say you should represent intersection by? And X is a member of C. You can see the way I've broken it down. Let me start all over again for your understanding. When you are given a question like this, you are asked to prove. What you need to do is to take the one of the part first. I'm taking the left hand side part first now. I now say let x be a member of all these parts now. Don't forget, I've already told you that wherever you see union, you put all there. And if you see intersection, put and there. Now, I now say that let x be a member of A union as the question is written here. Now, I now say x is a member of A, this union here, or x is a member of these two parts as well. This is what I did here. Now, I now split it further. I say x is a member of A, which is what is written here initially, or as it is written already, x is a member of B, and I've represented this intersection here by and x is a member of C. I've been able to bring it out like that. Now, after we've been able to do it this way now, we can now look at it and say that, oh, if it is this or that is that, which means that it is x is a member of A, or x is a member of this one, and x is a member of A, or x is a member of A. X is a member of A, x is a member of A, and or x is a member of B, x is a member of B, and x is a member of A. You know, what I'm doing here is that I'm using this x is a member of A to multiply all this particular expression that are separated with and. X is a member of A now, multiply by this, x is a member of A, and or x is a member of C. You can see x is a member of A here with this x is a member of B, x is a member of A with this x is a member of C. We have used this to multiply these two parts now. Now, I can now separate those expressions now into what I've done earlier. Now, so this one will now mean that X is a member of A. What do I call or? Union B. And means intersection. X is a member of what again? A union C, because X is a member of the two of them. Look at this, or union C. So in this regard now, there's a member, there's a member, there's a member. In that regard now, I can now say that X is a member of A union B, intersection A union C, intersection A union B. So in that word, you can see what we are given to prove now. I've been able to use it to prove it now. X is a member of A union B, intersection A union C. In other words, now I can now say that A union B intersection C is equivalent or is equal to A union B intersection A union C. Now, I've been able to prove this from this side for you now. Let me now go to this side. Say conversely, I'll go from here now. Don't forget, I have told you that you are going to say X is a member of everything here first. X is a member of A union B, as it is written, intersection A union C. That's the first thing you will do. Now, after you have done that, you can now say that X is a member of A. Union means what? Or X is a member of B. And intersection, that's what? And X is a member of what? X is a member of A union C. A union C. So which I can now split to become, this one is equal to X is a member of A, or X is a member of B, and X is a member of A, X is a member of A like this. What is this? Or X is a member of C. We have been able to have it in this order like this. So we can now introduce our particular values there back now, where we have this and. This is X a member of A or X a member of B. X a member of A and X a member of C. So we can now say that X a member of A here and X a member of A. So it cannot be X is a member of A, X is a member of A, and X is a member of A, or X is a member of B and X is a member of C. You can see this is X member of A belongs here. It also X member of A. I now pick it out as one X member of A. Or X is a member of B, and because those two are the ones that are relating with A, you can say X member of B relate with A, X member of A, X member of C relate with X member of A as well. So it is now X is a member of A, or X is a member of B and X is a member of C. So which can now be written as X is a member of A union, or it means union X is a member of B, intersection X is a member of C. You can see this and means intersection. And means intersection. Now, we go further to say X is a member of A. X is a member of A. This is union, right? Union. You now have to remove the X value inside the bracket now. Union B, put it in bracket, intersection C. Union B intersection C. What we do here is that we remove the X is a member that we put there, because X is a member of everything now. Now, we can now conclude that this one cannot be concluded that X is a member of A union B intersection C. We've written that. We can now say that X is a member of A union B intersection C, which is equivalent to, you can see there, that's what we have gotten now, which is equivalent to A union B intersection A union C. Intersection A union C. So when you combine the two equations now, combining the two equations, we are going to have A union B intersection C is equal to A union B intersection A union C. That has been the way you use in solving this kind of a question. You have been able to prove it. Take note of what you need to know there. When you are given a question to prove, take note that you make use of union as or, and you make use of and intersection as and you post those values in there appropriately. And don't forget, ordinarily, how you make use of or and your and in mathematics. It's also in probability. You have the value that you normally make use of or for. Or is what? Addition. Y and is multiplication. That is in probability. So please, we implore you to subscribe to our channel for you to be able to be having day-to-day information from our lectures room. Thank you and God bless.